Hi, the purpose of today's video is to look at one specific problem from the IB High Level Math Cambridge textbook. This one's a little bit different than a lot of the geometric sequence type problems that you see. They're being a little bit coy with their questioning. They're trying to get you to make a certain discovery about factoring. And it's a pretty cool trick, but it's hard to see the connection between geometric sequences, geometric series, and these factoring polynomials. So you might be inclined to think that this is a factoring problem, but instead it's actually a geometric series problem. So here's how it connects. The purpose of part A is to get you to recognize that you can generate the sum of the first four terms of this sequence without having to use the formula. That is to say, I can simply write that u sub 1 is just 1, u sub 2 is x, u sub 3 is x squared, and so on. You can actually, by putting in 1 for n, you can generate every single term in this sequence. Therefore, we can add up the numbers in the sequence to create a series that is a polynomial. So this is a third degree polynomial when I add the first four terms of that sequence. So somehow or other, we as learners are supposed to be able to come up with the s sub 4 equals this thing and somehow connect it to the question in B where it says factorize x to the 6th minus 1 into a linear factor in a polynomial of order 5. So here's where the connection comes into play. If they say polynomial of order 5, I can go back here and say, well, you know, when I added 4 terms, it was a third degree polynomial. It follows that 5 terms, it's going to be a fourth degree polynomial. And likewise, we would expect a fifth degree polynomial for a 6-term poly. So for s sub 6, again, I don't necessarily need to use my geometric series addition formula. Instead, I can just generate the sum as this specific polynomial. So x, or 1 plus x squared plus x cubed, and so on. Again, this is a fifth degree polynomial. This is not x to the 6th minus 1. So it's really difficult to understand how, again, that you were supposed to come up with factoring. However, the one clue that you can take away here is not once in this problem have I used the sum formula for a geometric series. So maybe I don't know where this is going, but I'm going to feel around a little bit and see what happens if I did use my sum formula for the first 6 terms of this geometric series. Turns out to be, oh, look what happened. When I use my sum formula, I get x to the 6th minus 1. There's some other junk going on here, but I think I'm onto something here. This x to the 6th is the first 6 terms added together explicitly. This s sub 6 is the same truth, that is, it's the same sum, but it is using the more sophisticated shortcut formula. But it must be true that s sub 6 has to be the same whether I express it as a polynomial or using my formula. So once I set those two equal to each other, since I know that that happens to be true, that's when I discover that if I just multiply by x minus 1, I will have x to the 6th minus 1, and on the other side, I have a linear factor times a polynomial of order 5. So this is kind of wackadoo when you think about it. X to the 6th minus 1 is a simple little guy, but it actually factors in x minus 1 times this whole fifth degree polynomial here. It's kind of dope. Anyway, just to verify that x to the 6th minus 1 is equal to the correct polynomial times x minus 1, I went to Desmos and graphed the two and showed the same graph. So I hope you find that helpful. Have yourselves a nice day.